We're going to be looking at triangles and some of the properties regarding triangles, as well as how to construct a specific type of triangle later on in this lesson. So first things first, I know we're used to seeing triangles. It's a three-sided figure. Technically, it's what's known as a polygon. It's a closed figure formed by a finite number of coplanar segments. So basically, a triangle is a three-sided figure. A square is a four-sided figure. Pentagon is a five-sided figure. Hexagon, six-sided figure. So it's a finite number. So depending on the number of sides of a figure will dictate the name of the figure itself. The vertex is intersecting points. So if I were to look at a triangle in this case, since our lesson is labeled triangles, so if I were to have a triangle here, each individual point is going to be a vertex. So a triangle will have three different vertexes. Now, it's not really important to know that each point there is a vertex. It is a definition that we have in the classroom here. And the triangle sum theorem states, if I add up all the angles inside a triangle, I'm going to get 180 degrees. So we have 1, 2, 3 different angles here. So if I were to add up those three angles, I'm going to get 180 degrees. Now, there are a few different types of triangles. One of them is an acute angle. Basically, what this means is a triangle where all three angles are less than 90 degrees. So A, B, and C, these angles, all three, are going to be somewhere between the 1 to 89 degree range. An equiangular triangle means all three angles are the same. So this means if I want to know what an equiangular triangle is, we know that we add up the angles, we get 180. So we just do 180 divided by 3, which means each angle is going to be 60 degrees. So 60, 60, and 60 degrees. Equiangular. An obtuse angle, or an obtuse triangle, is a triangle where one of the angles is greater than 90 degrees. So this means M and L can be acute angles, but here we see angle K. Angle K is going to be greater than 90 degrees. And a right triangle is a triangle that has a right angle, or 90 degree angle. So in this case, we see the little square here. We have angle H. It's a right angle, therefore we have a right triangle. So to classify each one, we're going to say whether it's acute, equiangular, obtuse, or right. So we have 4 different ones. Remember, an acute triangle is a triangle where all three angles are less than 90. Equiangular, all three angles are the same. Obtuse means one of the angles is greater than 90. And a right triangle means we have one of the angles being 90 degrees. So I take a look. 49, 34, 97. 97 being greater than 90 means we have an obtuse triangle. Here we see all three angles are 60, so therefore it is an equiangular triangle. Triangle PQR. What they like to do is they like to put triangles together like this. So here we see we have technically 3 triangles. We got triangle PQS here. We have triangle QSR and the big one PQR. We want to take a look at PQR. So P to Q to R. This is the triangle we're dealing with. So I'm going to take a look at each angle. So here at angle P we have 45 degrees. Angle R we have 31. And up here at angle Q, we have 45 and 59 degrees. So in order to figure out what kind of triangle we actually have to add these two angles. So step 1, 45 plus 59 gives me angle PQR. So if I add them together, I'm going to get 144 degrees. Is that angle less than, greater than, or equal to 90? It is greater, therefore obtuse. We can also look at the sides of a triangle to state what kind of triangle we have. So an equilateral triangle, and most often we can use angles and sides interchangeably. There's a unit later on in the year we cover all the different theorems about triangles and relationships between angles and their respective opposite sides. Equilateral triangle means all three sides are the same or equal. So when we look at that, you're going to notice in diagrams later on we're going to be using slashes. So if all three sides are the same, 1, 2, 3 slashes through the sides, that tells me here that all three of these sides are the same thing. Each has a single slash through them, therefore all three sides are the same. An isosceles triangle, we have two sides are the same or equal. So again, we're going to use slash. So a slash through this side and a slash through that side tells me these two sides, T to R and T to S, that tells me those two sides are the same. So as long as two sides are the same, we have isosceles. And then scalene triangle, we have 0 sides that are the same. So x to z and z to y and x to y, they're all different measurements. So here we're going to classify equilateral, where all three are the same, isosceles, where two sides are the same, or a scalene triangle, where 0 sides are the same. So here we have the triangular guitar here. We have sides of 18.5, 16, and 16 inches. I see we have two sides the same, therefore it's an isosceles triangle. Triangle JKM if M is the midpoint of JL. So again, they put two triangles back to back to make a really large one. So we want J to K to M. J, K to M. So this triangle right here, that's the one we're going to worry about. If M is the midpoint of JL, middle again means it's halfway. So if the full way is 1.5, first thing I need to know, what is JM? I divide 1.5 by 2. And I'm going to get 0.75. So I know J to M is going to be 0.75 because M is the midpoint. So all I have to do is divide the whole thing by 2. So if the J to M is 0.75, that also means M to L is going to be 0.75 as well. Now notice here we have a little red slash through ML and a little red slash through KM. This tells me that those two sides are the same. So M to L being 0.75 also means that K to M is also going to be 0.75. So if I take a look at this triangle here, I have sides of 0.75, 0.75, and 0.75. All three are the same, so we have an equilateral triangle here. We can also use the markings to figure out measurements algebraically. So here we have to figure out the sides of the isosceles triangle of triangle ABC, where we have side AB being 9x minus 1, side AC 4x plus 1, and side CB being 5x minus 0.5. Again, here we have markings, red mark, red mark. This tells me AC, and CB are going to be the same. So if two things are the same, they are equal. So what I can actually do is take 4x plus 1 and 5x minus 0.5 and set them equal to each other. So I can state, because of these markings here, that 4x plus 1 is equal to 5x minus 0.5. And I'm going to solve for x. So usually it's easier to move the smaller x over, so 4x being smaller, I'll subtract the 4x. So I get 1 equals x minus 0.5. And what I want to do now is move the 0.5 over, so I'm going to add 0.5. So we get x equals 1.5. Now that I know what the value of x is, I can plug these values into the equation here, or into each side to figure it out. Now again, because we know two sides are the same, I'm going to pick the easier of the two here to use. So 4x plus 1 or 5x minus 0.5. 4x plus 1 might be a little bit easier. So 4x plus 1 is one side. So we'll plug in 1.5. So we have 4 times 1.5 plus 1. And we end up with 6 plus 1. Giving me 7. So I know AC equals 7. And because AC and CB are the same, we also know that CB is going to be 7 as well. Last but not least, we have to figure out the length of AB. So AB is 9x minus 1. So we plug in 1.5. So 9 times 1.5 is going to be 13.5 minus 1, and I get 12.5 as measurement of AB. So again, we solved algebraically using a two-step equation, and then we plugged our answer in to figure out the lengths. And we can do the same thing based on what we know. We have an equilateral triangle here, so we need to figure out the lengths of the sides. So equilateral triangle means all three are the same, all three sides are equal. So as long as I can figure out the value of y, all I have to do is plug it into one of the three expressions, and I will have the measures of all three sides. Usually in this situation, pick the ones that you're dealing with smaller numbers. So 2y, 3y, and 5y here on these sides. Well, the 2y plus 5 and the 3y minus 3, they're smaller values of numbers than the 5y minus 19. We can set them equal to each other because they are the same. So 2y plus 5 equals 3y minus 3. Again, move the smaller value of y over. So 2y, we'll move it over by subtracting it. So we get 5 equals y minus 3. And then we'll add 3 to both sides. And we get 8 equals y. Now that I know the value of y, I'm going to take it and plug it into one of the sides. So this previous problem, we had two sides the same. So I plugged it into one, and I was able to get these two sides. And then I had to do it again to get the longer side. But because this is an equilateral triangle, I only have to do it once, and I know the length of all three sides. So pick the easiest one, 2y, 3y, or 5y. 2y is usually easier. 2y plus 5. And I plug in 8. So 2 times 8 plus 5 gives me 16. Plus 5 giving me 21. So all three sides are 21. So GF, GH, and FH are all 21 units. And we can basically answer all these problems being asked in different ways. They're essentially the same question. So we have to classify based on the sides according to the angles. What are the legs? What are the opposite angles, opposite legs, etc. So here we have triangle DEF. EF and ED are the same, and angle E is 90 degrees. So they've marked it off for us. So according to the sides, again, sides are equilateral, isosceles, or scalene. 1, 2, or 3 sides the same. 2 sides are the same, so we have an isosceles triangle here based on the sides. According to the angles, again, I have to look at what kind of angles. Am I dealing with an acute triangle where all 3 angles are under 90 degrees? Do I have a right triangle with a 90 degree? Do I have an obtuse triangle? Here we see we have the right angle in there, so therefore it is a right triangle. What are the sides of the triangle? What sides are the legs? When it comes to a triangle, you have 2 legs and a hypotenuse. The 2 legs are the shortest sides of the triangle. The hypotenuse is the longest side, and the hypotenuse is always going to be across from the largest angle. Now, in a right triangle, the right angle is going to be the longest or the biggest angle. So this means the side across from it is the hypotenuse. So the other 2 are going to be leg and leg. So the legs are DE and EF. Those are the legs. And we just said the side opposite the angle is going to be DF, the hypotenuse. The angle opposite EF, so here we have EF here, so opposite means across from it, not next to it. So I have to go across, and I see it as angle D. We'll use the 3 letters, so angle, we can say it's angle FDE, being opposite. And then the angle included between EF and FD. So EF and FD, what angle is in between them? Well, the angle is created right there, so angle EFD. Now we can actually use compass and ruler to create an equilateral triangle. So here we have the instructions on how to do it. It says draw circle J with center J, radius JS. Draw circle S, center S, radius SG. Label the intersection as M, and then join S points S, J, and M. Sounds kind of confusing if you don't know what you're doing. It's really not too difficult. So basically what we want to do is we want to, first things first, plot a point. Just put a point anywhere and label it center J. And what we want to do is we want to draw a circle around this point. So this means we're going to take the bullseye part of our compass and place it on our point. Now what we want to do is we want to open up our compass a little ways where we got enough space. And I'll change the color here. So we're going around circle J, and we're just going to draw a circle around it using our compass. Now the radius is from the center point of a circle to any edge, to any point on the edge of the circle. So here we're just going to put a little dot on the circle somewhere, and we're going to say that is point S. So from J to S is what's known as a radius. It's from the center of the circle to the outer edge of the circle. Next things first, notice I did not move the opening of the compass. What I'm going to do now is I am going to put my compass bullseye part on point S, and I'm going to draw a circle around that. And hopefully, if I am correct, JS, so therefore now I can draw a circle around there. So notice that the circle around S went through point J as well. What I now have is 2 points of intersection, 2 intersections where I could pick one of the points. I'll pick the top point, and we're going to label this as M. And what I'll do now is I will connect J to M, M to S, and J to S. I've now created a equilateral triangle. And I could have gone the other way. I could have used the intersection down at the bottom as well. I could have said this was M instead. So I'll label this as M1. This is M2. And I could have gone from J to M2 and from M2 to JS and then across to JS. So I actually have two equilateral triangles here. But that is how you construct a equilateral triangle. Basically, you draw a circle and then a second circle, and then the point of intersection would be the same distance away. Now here we have a slight word problem with the diagram below. We have Cedar City boasting 2 city parks and wants to design a third. Planning committee wants all 3 parks to be equidistant from each other. We have a sketch here below with Park 1 and Park 2 labeled on the graph, and we need to figure out where Park 3 is going to go. If it's equidistant from those 2 points, that means basically what we do is the same thing we just did. We have to use our compass. We are going to place our bullseye on point 1. We're going to open our compass. So that way there we can make sure our pencil is on point 2. And we are going to draw a circle around point 1. We're going to swap it so that now our bullseye is on point 2 and pencil is on point 1. We're going to draw a circle around there. And we're going to look for the points of intersection of our 2 circles. So here, up here at the top, is possibly Park 3, and they said Park 3A. And down here at the bottom could be Park 3B. So this means Park 3 would be the same distance from point 1 as it is from point 2, and as point 1 is from point 2. And that is constructing equidistant points, constructing an equilateral triangle, and all the properties regarding triangles based on their sides and their angles.